So the last class we studied about regular reflection, diffuse reflection. The next thing that we study, there are a lot of new things that you will study in this chapter. This concept which we will study is reflected light, and this is interesting again. Reflected light can be reflected again. Reflected light can be reflected again. And what do we mean from here is that we will say, suppose you have a reflective surface, okay, and we will see a lovely application of this also. So let's say we have a reflective surface and there is a light ray which is coming and hitting this reflective surface. Say suppose this is a light ray which has come and it has hit this reflective surface. Do you agree? Itna samajh mein aaya? Right. So if it is a reflective surface, I'm supposed to etch it. What I'm doing right now is the voice getting captured here. So I've etched it. And as our concept goes, that we should also have a normal. By now you know, right, that you should have a normal. So let's make one normal out here and let's make it obey the law of reflection, which is the angle of incidence should be equal to the angle of reflection. Okay. So this is my array. This is my reflected ray. Tell me, children, have you understood till here or not? Now, this is the incident ray. So if I try to write it, this is my incident ray and this is my reflected ray. This is my reflected ray. What we are studying here is reflected light can be reflected again. So when you call about this reflected light, this is actually this portion, okay? Now, can be reflected again. This is what we are trying to study. So say, suppose I have another reflective surface out here and say, this is my second reflective surface, okay? I have another reflective surface in this manner. Right? Oh, now, yeah, I need to change the orientation. This is the normal will become, or the incident light is almost equal to the normal. Okay, so let me make the reflective surface like this. So this is my reflective surface. So I can now make a normal out here. So let's make a normal, and my second normal would be what exactly? Okay, so this is my normal. And this ray can be reflected again. Now that's what I'm showing by the color red out here, okay? Yeah, it's reflected again. So when we say can be reflected again, now this is can be reflected again. Now it can undergo multiple reflections based on how many reflective surfaces hits, and that's exactly what happens. Darling, you open the chocolate later, you can draw diagrams and understand also. Okay, so you get to know that the reflection that is happening in this room. Now we have got a source of light, say the tube lights, rather the ceiling or out there. From there, rays are coming, they're hitting on objects. It's not that only one ray comes, hits on the object and goes into the eye. The eye is getting the rays from this, but the brain does a lot of correction. Actually, there will be an image created by, say, a direct ray. The next ray might go here and hit you. So a lot of things are happening. At grade 8 level, what we try to study is the application part of it. And that is very interesting. Application. Just like, have you seen, you studied about lateral inversion. The application of that is done in where? When you write the words ambulance. Now the application of this concept is seen in two devices. One is a periscope. And in our school days, we used to make a lot, okay? Periscope, and the second is kaleidoscope. Now we'll see the periscope in detail and we'll discuss about the kaleidoscope also. Yeah, mirror rooms also. Specifically, when you go to the barber's shop or you go to the beauty salon, you always see so many numbers of, you sit here, there's a mirror right behind you, there's a mirror in front of you. So if Mishka is sitting, she sees Mishka, 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 Mishka. All these are possible because reflected light is getting reflected again. So let's see periscope. Now, periscopes are actually used by submarines. When the submarines go down the water, then a periscope allows you to see something which is beyond your line of sight. What do you mean by beyond line of sight? It's the concept is like this. Say this is a person. The person's line of sight will always be horizontal to the ground. This is his line of sight. Right. Now suppose there is an obstruction out here. Say suppose we create an obstruction. For example, let's say we have created an obstruction out here. Now we cannot see what is beyond the obstruction. The periscope will help us. So let's see how a periscope's construction happens. So a periscope ideally, periscope will have a very simple form of a periscope that I'm trying to draw. Right. Now a periscope consists of two mirrors, two plane mirrors. And what is interesting is the angle at which we align them, the mirrors are aligned at 45 degrees to their respective bases. This is aligned at 45 degree. Okay. Now see the interesting part. If this angle is 45 degree, this is 90 degree. So this has to be 45. Do you agree or not? This is isosceles triangle, right? And this is your mirror. This is the mirror, right? And the second mirror is also at 45 degree. So this is also 45 degree. This is 90 degree. 90, 45, 45. Have you understood? Now, on this side is our observer's eye. So that's how you can make lovely eye, right? And let's say, let's add a little bit of more drama. Without drama, there's nothing, you know. So let's say that this is a wall level. Okay. So we make it something like a wall. Right, this is a wall, and on the other side of the wall, say for example, we have a lovely big tree, somewhat like this. There's a tree out here, and in this tree we've got one lovely little bird. The beak of the bird is bigger than the bird's body, so please excuse me on that. Right, a lovely little bird, and due to the wall, the person is not able to see, right? The person is not able to see. Now what will happen? Let's see. Okay, now this is what is interesting and mazedar. So light rays will come from here and they will hit this mirror, the first mirror. They'll hit this mirror. Is this understood? First understand. Kya ho gaya, Mishka? You're continuously yawning. Okay, this will hit the mirror. And once it hits the mirror, you should also have what is known as a normal out here. So let's make that normal. This is the normal. And then this light will get reflected. So if you go by parallel lines, look, this line is parallel to this line. So if this is 45 degree, this angle will be 45. So the angle of incidence will also be 45. See, this is 45 means this is also, this one is also 45. If this is 45 means this one is also 45 because it's up. Understood? So it will get reflected and the reflection angle will be how much? 45 degree. Obeying the laws of reflection, the reflected light should also undergo exactly 45 degree. So now it becomes after this. So let's make one more normal out here. Okay, so again here the same angle will be created. Angle of reflection 45. So if this is 45, now see, this is 45. That means this is also 45, alternate interior. That means the angle, now this becomes the angle of incidence, okay? This will become the incident ray. The reflected ray becomes the incident ray for the mirror, second mirror. So let's say that this is mirror 1. This is mirror 1. So whatever is the reflected ray of mirror 1 becomes the incident ray for mirror 2. So this is mirror 2, right? And finally, what will happen? Finally, our friend should get a reflected ray, which will come and hit straight away the eye of this person. Like this. So if you want to correlate our diagram with the heading, though it becomes a little bit complex, so reflected light, which is this, can be reflected again, which is this. And say suppose our friend Shreyas was thinking that nobody's looking at me, and he was bathing out here, then put one periscope and aram se see, our friend is having a nice little bath. Understood? There's a joke like that. So our friend Shreyas actually went to UK and he started speaking too much in English, right? And then he went to the washroom, the bathroom, and was having a shower. And his best friend Ryan was outside. And he told that since the door does not lock properly, Ryan, you hold it tight. So Ryan has held the door and Shreyas is having bath inside. But he has become very British, you know. So he started singing song. And the song was like this. There was a cold day. Hear me. There was a cold day. And Ryan heard it as there was a cold day. So he opened the door. After that, whatever happened is left to your imagination, as you understand what is a periscope. Did you understand the story, Mishka? The Ghana was, there was a cold day, us din ek thanda din tha. And this fellow is not so good in English, so he heard it as, there was a cold day. So there was a cold day. Yes. Samajh mein aaya? And one MP4 file was created. Somebody has burnt milk. So have you understood what is a periscope? A periscope works on, you can light down the line. A periscope works on the principle that reflected light can be reflected again. And a periscope typically has two mirrors. What is important is both the mirrors are 45 degrees with their horizontal. Also, that is a periscope that you meant. Look at this periscope miniature version. Okay? So periscopes are 45, the mirrors are 45 degrees with their what you call bases. As such, both the mirrors are also parallel to each other. If you see, the mirrors are also parallel to this mirror is parallel to this mirror. So light rays will come, hit here, angle of incidence will be 45, reflection 45, which means against incidence 45 for this, and again angle of reflection will also be 45, means ultimately it will become parallel. No, then it won't work. This is very important. That's what used to happen with us when we used to make it in project work. You have to make two slits out here where we used to fit the mirror. If the slits are not okay, your periscope will not work. So the first thing that is required with periscope is 45 should be there. We can still, but viewing won't be that. The best viewing happens when it is 45. A periscope allows us to see something where there's an obstruction on our line of sight. Abhigya, we started direct and inverse variation. The video is also uploaded. We have not done any mathematics. आराम से सो के देखना उसको बैठ के. Or else, if you can play YouTube on your TV, play it on TV and आराम से देखना. We have not done any math. We just did one problem, so you don't lose out anything when you come next time. My only request is when you come for the next class, do watch the video and come. And there's no rocket science. You'll understand it. Okay, sir. Is periscope understood? So what all questions can we expect in periscope? Clear? Shall we go to the next one? Shall we understand what is a kaleidoscope? Okay. Now in kaleidoscope, I won't draw the diagram. You can get it in books. See, a kaleidoscope is something like this, okay? The best way to explain you what is a kaleidoscope is I'll take these three remotes and that will make you understand. Kaleidoscopes used to be very familiar in our days, where if you go to semi-urban places, semi-urban, if you go to rural areas, mela hota hai na, fair and everything, there it is sold a lot. So we will have three mirrors, which are typically like the sizes of remote control sizes in width, but all three mirrors should be of the same size. So the three mirrors are taken in such a manner that a sort of equilateral triangle formation is made. Equilateral triangle, okay? So this is what how a kaleidoscope looks like. There will be equilateral triangle with three mirrors, and then girls have that bangles, no, broken bangles. So anything that you see from here, there will be multiple reflection, and it looks very beautiful. So what they do, they take broken bangles, broken bangle pieces or glass pieces, and they put it on this side, and then you are supposed to see with that into the sunlight side. Yeah, so that's called a kaleidoscope. So a kaleidoscope also works on the principle of that reflected light can be reflected once again. So a question that you might get is, give two examples where we have the application of reflected light can be reflected again. So periscope is one and kaleidoscope is one. What is a periscope used for? The uses of periscope is for marine navigation. This is more or less used for a submarine. So we use in marine navigation. So wow, excellent. I am recommending your name for Nobel now. So done. Okay. So go to the next one. It doesn't make any sense what you will add value now by coming now to the class. So kaleidoscope and periscope, fine. Mirrors at 45-degree. Periscopes uses in marine navigation. Kaleidoscope is an entertainment device where we use the concept of reflected light can be reflected once again. Are we fine on this? Okay. So at this juncture, we will now go to something more interesting. That is the a concept called dispersion of light. These all you will again study in grade 10. Same topic, dispersion of light. Okay, so let's understand what is yeah, 7 fragments. So in order to study diffraction of light, we need to understand a little bit about sunlight. So sunlight means this is the source of light now is our sun. So sunlight comes from where? Sunlight comes from the sun. So although not at your level it's not that much required, the sun will give us something. We think that the sun only gives us sunlight at grade 8 level. Well, as I have already discussed it when we started the chapter. Do you remember the first class which we had introductory? So the sun actually gives me something which is known as the EMS. This is high level for you, but still try to understand. EMS stands for the word, the electromagnetic spectrum. What it is, don't break your head now. Okay, electromagnetic spectrum, which means it gives me a variety of things, and within this electromagnetic spectrum, there is a very small portion which is known as the visible light. Visible light. Right? And this visible light is actually composed of 7 different colors, which we usually represent as VIBGYOR. 7 different colors, which is known as VIBGYOR. Okay. So how to understand dispersion of light? This was actually done by Newton. So for this, we need another device, which is known as a prism. As student of science, you know, some objects of interest should be there at your home. They're not very costly. Next time when you go, you can buy. You can keep one prism. You can have one magnetic compass, right? These are all very interesting things. You can have one concave mirror, one convex mirror. They're all available at any science store. So we have a prism, and there are various orientations of prism that we get. But for your level, we will be taking an equilateral prism. Okay, this is an equilateral prism. So what is a prism? It's like a glass slab, a thick glass slab, in which you have cut it out equilaterally. Has anyone seen a prism? Okay, fine. So it is an equilateral triangle from all sides, right? So the angles that we will be having here is 60-degree, but you do get other what you call shape prisms also. You get 60, 30, 90 prisms. You get 90, 45, 45 prism, but we will be talking about the 60, 60, 60, which is an equilateral prism. So the sunlight that we see, or the visible portion of sunlight that you see, is always white in color. So this particular sunlight is white in color, and the white color actually is comprised of 7 different colors, which are known as VIBGYOR. Okay, so let's try and understand that part now. So if sunlight, sorry. So this is the incident ray, and this you'll study more details in grade 10. So this is your incident ray, and the prism has the ability to split it into all 7 fragments. Okay, it will actually split it into the 7 fragments. So on this side onwards, you will get 7 different colors. And 7 different colors, right? So this side is the white sunlight. And this is a prism. The prism splits it into 7 colors. This side you will write VIBGYOR from the bottom. This is how it is. Red is at the top. Red undergoes the minimum deviation and violet undergoes the maximum deviation. Now, this process of splitting of white light, and this white light need not only be from sun, it can be from a lamp also. Process of splitting of white light into its 7 constituent colors is actually known as dispersion of light. This is known as dispersion of light. The process of splitting of white light into its 7 constituent colors by a prism. You can also add that word, by a prism. So if you have aquariums or other things at your home, or sometimes wristwatches, and it's post lunch in your school and the sunlight is coming from one side of the window, you must see that when it hits somebody's wristwatch, you will see a band of colors on the floor. Okay, that's very common, and people start playing with it. So these won't have clear boundaries, they will have overlap. Typically, like in a dupatta and all the colors that we have, this will have overlap. They won't have crystal clear boundaries that this much is violet, this much is indigo, this much is blue. There will be a little bit of overlap, but a band of 7 colors would be seen. So this is known as dispersion. This was actually discovered by Newton. So based on this, there is another interesting thing which is also known as the Newton's colored wheel. Have you seen the colored wheel? So you can actually create a colored wheel, and that is, yeah, very good. We can create a colored wheel, and this wheel will have, you know, how many? 7 concentric circles. So we'll have 7 concentric circles, and the seven concentric circles will have the 7 colors within their rays. And once you spin this at a high speed, all you will see is white color. So if you spin this, then you will see that this wheel appears, the wheel will appear white in color to you. Yes, somebody was asking some question.
No, sir, I was about to say if you spin it, it becomes white.
Yeah, it becomes white, and that's how color combinations are made. The base color always comes, you can get it. Then we have the models. When you study color graphics, you'll understand something called the RGB model. The red, green, and the blue. Then we have the CMY model also. The white light, this white sunlight, is white light is a better word. White sunlight, you can use the word white light. It can be sunlight, or it can also be from a lamp. Okay, but it should be white. So we have another, if you go for graphic study, in many printers will ask you, generally all the printers that we use are printers which work on RGB model, like mug printing and all. If you want to give your own picture, then they will ask whether it's on the CMY. CMY is cyan, magenta, yellow. These are the 3 base colors. Based on these 3 colors, any sort of color combination can be created. In fact, next time if your house is getting painted, or sometimes go to a paint shop. You know how a paint shop, if you see Asian Paints, or if you see Nerolac or somebody, you will see the shade card is having so many different colors. Does the shop keep so many different colors? No, the shop doesn't keep so many different colors. So say suppose this particular color, okay, this is known as, this is peppy yellow or something it was, okay. So this will have a shade called 9697 with that particular brand. Now this is from Asian Paints, so they will have peppy yellow 9697. So you go to the shop, then they'll ask you, what type of paint do you want? Do you want washable or do you want standard paint? So if you say washable, then the cost goes up. These are like washable paints, so in that case the cost will go up. All will have a base white color, so that white will be a little bit costly. That's the base. Any color you take, he will take the base. Then he'll ask you how much you want, half liter, 1 liter. You say 1 liter, so he'll take 1 liter base. Then he'll confirm with you. Color, you said 9697, then he'll match it. Peppy yellow, confirm, confirm. After that you can't say. Now he will open that white and he'll just place it below the machine. And that machine is like a coffee blending machine. Like you want cappuccino, latte, steam and all comes up. There will be 3 nozzles, 3 colors. Every color is created from 3 colors. That is a RGB model or a CMY model, cyan, magenta, yellow. And he'll enter on the computer and then it will be held. The computer will just make the machine punch those drops in that much quantity only. Cyan, magenta, yellow, those 3 colors will only fall. After that, he'll lock it and put it in the tumbler section. It's all there we have so many shops in Kalimandri and all. Sometimes just stop. That's how you learn. Even if you're not buying, just go and ask to the guy, are you going to make some paint? I just want to see. Then he'll put it in the tumbler and the tumbler will rotate that dabba many number of times, spinning and all, it will just tumble, and then he'll give it to you. Exact same color will come up. Now say tomorrow you want to touch up a little bit more portion out here. You can get the same paint. It will come exactly same, not a great dense, not a great light. So how are they created? From the same base model of CMY, cyan, magenta, yellow. So is this understood? Now in grade 10, you will also study that dispersion, when dispersion happens, these light can be again converted back to white light. If you have another cousin brother prism of it, another prism which is exactly its cousin brother, and you keep that prism in this orientation now, okay? Let's have another prism which is exactly the cousin brother of this prism, and keep that prism in this orientation, like this, say suppose, okay? Have you understood? One prism back to back another. This one will again combine it back and you'll see white light. So white on this side, white on this side, and the broken fragment on this side. This you will study in grade 10 about this. Have you understood? So is dispersion of light clear as a concept? What is dispersion of light? The phenomenon by which white light can be split into 7 constituent colors using a glass prism is called dispersion of light. And if you have 2 prisms back to back which are identical in their geometry, then they can again be combined back, very good, to the white light. Okay, so one of the application of I will discuss this whether this is in your book or not. Anyways, in grade 10 you will study the rainbow is one of the fantastic natural phenomenon which actually uses dispersion of light. Now if I say, now let's try and understand. If I say that the rainbow uses the what you call phenomenon of dispersion of light, right? Then at that moment, you as a person should start thinking about some things which you will need. Number 1, you need white light. Okay, otherwise how is dispersion happening? Then number 3, I'm writing, obviously if it's a rainbow, I would need an observer also. Otherwise, who gets to see the rainbow, right? And one of the most important object would be that I need a prism also. Otherwise, how will that splitting happen? Now, the entire interesting part is this part, the prism. The prism is formed by water droplets. Water droplets, okay, that remain suspended. That remain suspended in the air after rain or during rain. Okay, that remains suspended. Now, if it's raining torrentially, you don't expect to see a rainbow. Neither if it has not rained, you will not see the rainbow. That means when a rainbow is formed, then the sun and the rain should always happen simultaneously. And they should not be at a very high speed, because I want the water droplets to be suspended. Now, how it happens, it's like this. Now, that geometry is also interesting, which we actually see in grade 10. So you'll have the sun, and the water droplets would be suspended. These are the water droplets which are actually suspended, right? These are the water droplets, and each of these droplets will be acting like a prism. The observer should always be in such a position, that the sun should always be behind the observer. You can never see a rainbow if the sun is in front of you. That's also beauty. Just see now. What happens? We'll have our what do you call, white light, which will go here. This white light will undergo what? This white light will undergo dispersion, and then you will get your band of vibgyor, which will come to your eyes, and then all other colors we can add in between, whatever you want. And that's actually the way you, what do you call, the way you see a rainbow, because we always have the spherical horizon vision. If you stand on a field, then you feel that the cloud is going like a football and touching the ground. So everything appears like a spherical vision. So the apparent apprehension you will have is that you are seeing it in a spherical, because the horizon is always spherical. Now it's a band. The horizon is, see, if you are standing on a field, how do you see the cloud? The cloud appears like a dome. The sky is like a dome. It appears as if it's going and touching on the other side. So that field actually makes you feel that you're seeing a bow, but it's actually a band. So for rainbow to happen, what is a rainbow? A rainbow uses the principle of dispersion of light. That means if it is dispersion of light, I need white light, and white light will be given to me by the sun, right? I need a prism. The prism will be contributed by the tiny water droplets which have remained suspended. So if it is raining torrentially, at that time the rainbow won't be there. The rain should just get held up or drizzling very slowly, and the sun should be shining simultaneously. Then only the rainbow can be seen. The rainbow cannot be seen without the sun. And obviously you need to have an observer who will be actually viewing it. And the sun's position should be always behind the observer. So the rays would go and hit these droplets, and the observer sees a band of colors in a hemispherical manner, which is known as the rainbow. They won't be able to see. You'll be seeing the sun. That is very correct. You'll already be blinded by the sun. Understood? In our places, in rural areas, many people say when it rains and the sun shines parallelly, then they say fox marriage is going on. So these are old rural like stories. Then many places is there where it doesn't rain, like drought situation comes up, right? It's very peak summers. So people will take frogs and conduct their marriages. These are some rural beliefs and practices. If you get frogs married, then the rain gods get pleased and it starts to rain. But you guys will not believe because you all are modern guys. So if you go to rural places, you'll see. You can Google frog marriages and rainfall. So now there's no link. That's why these are rural beliefs and stories. Yeah.
You take a and then the color just come on the wall or something.
Come on the floor or something. Yeah.
But in the rainbow,
It's all the droplets. It is not landing anywhere. See, try to understand. So in front, the sun is behind me. There is a lot of droplets of rain which are suspended. They are like a screen which I am not able to see. So the droplets will be suspended in what manner? Straight. But the human vision about the horizon is how? Always curved. It appears that we are inside a football always, right? Or you have that Cadbury's gems. Have you seen that gems like a dome? So you're like a small insect inside that dome. So for you, it will all be scattered in a hemispherical. So each of them are giving me that. So that's why in a rainbow, you don't see the, what you call, the dispersion as beautiful. Not as, I'll not say the word beautiful, as clear as in a prism. In a prism, you'll see a lot of bands. But in a rainbow, you can't, if I ask you, there's a rainbow out there, to show me where is violet, where is indigo, you'll see a slight of blues and violets and reds, some touch of yellow. You don't get to see everything. Clear? So what all applications? There are a lot of application related things you studied in this chapter. Number one was lateral inversion, which is actually applied in an ambulance. The way you write the letters. Why? Because they're written intentionally in the reverse order, so that when an ambulance is behind you, the reflection of the letters ambulance on your rear view mirror falls in such a way that lateral inversion takes place and you see the right orientation, thereby giving way to the ambulance to proceed ahead of you. That's number one. Number two, reflected light can be reflected once again. Application being prism, periscope. In a periscope and a kaleidoscope. Periscope we deal more in detail. We have two mirrors in which one mirror will first take the incident ray, reflect it to the second mirror, for which the reflected ray of the first becomes the incident ray for the second, and again undergo. The angles are always at 45 degree. Clear? And a periscope is used for marine navigation. Then kaleidoscope is also it's an object of entertainment or a toy, in which also three glass slabs are actually glass mirrors, so plane mirrors are actually inclined at 60 degree to each other, which gives you multiple, what do you call, images, and with a lot of colors and broken bangles, you can see many nice, beautiful orientation. But this is like an object of toy. Any questions so far? Fine. Okay. Yeah.
Tube light is not white light.
Tube light is white light. You can take it.
So
Lamp also.
even
Tube light, you won't get the scattering as good as in the case of lamp. In lamp, you'll get. The best is use it during the daytime and sunlight. Sunlight will give you the best one. Okay? So go ahead. A little bit more. Okay. And then after this, we come to a little bit of part of biology, which is the human eye. Now, if you go to grade 10 class videos, then there is a chapter, you'll see a playlist called Human Eye and the Beautiful World. Achha, have you seen that? So there's a Human Eye and Beautiful World. That same drawing, the same drawing we will be drawing once again. Okay. So the eye, the human eye is a wonderful creation of nature. It is analogous a lot to the camera. Okay. It's a lot of analogous to the camera. Now the camera means not the DSLRs and all. They have the R time. Have you seen a film roll? Used to have cameras with film roll inside it. Okay. So let's see some basic comparison between a camera and this. A camera will usually have, first of all, a camera has a lens cap, right, which protects the lens. You have an eyelid. You have eyelid, not cornea. You have an eyelid. Agreed? Okay. If you go for good cameras, then another thing you'll, before the lens you'll have is known as something called a filter. A filter is a small circular glass that is fitted in front of the lens. So similarly to the filter will be your cornea, right? They have a lens, you also have a lens. You have a film and you have what is known as a retina. Job is same. Now a lot of things happen here. Between this to this, the camera can have something which is known as aperture. Like aperture is how much has the lens opened for the light to enter. Then we will have something which is also known as the shutter speed, right? All these things are also controlled here. We will have two things called the pupil, and we will have something called the iris also. So let's understand how these things happen. Okay. So it's easy. So the human eye is typically a construction which is like this, right? So the outer surface, we are not drawing the eyelids out here. We are drawing from the cornea portion. So let's say that this is the white bulgy portion that you see. That is known as your cornea, right? This is the cornea, which is the first part of your eye to get injured. When you have an injury, is the cornea. That is the first thing that gets injured. So this is your cornea, and the cornea is protected through for dust particles and other. Doesn't give you a mechanical protection, like if somebody hits you, you still get injured from dust and other things. It is protected through what? It is protected by your eyelids. Okay, so this is your cornea. Now after cornea, now this is the eye. That is, how to say, now look at this. This is a mouse, right? The drawing that you are seeing right now, you are seeing the mouse drawing from this view. Have you understood? You're seeing it from this view. So then we have an arrangement here. Which is known as the iris. Now let us understand what an iris is. Okay. Have you seen some movie scenes and all where they show you an aircraft and they show you just the engine portion of the aircraft, and the turbines have just been started, so they'll show you a spiral rotation sort of a thing. So the iris is typically something like, let's say I have got three type of plates out here, three different type of plates, and these plates can actually rotate like this. They can close and they can also adjust in such a way that you can create an opening out here. I hope you are able to understand what I'm trying to say, right? There are three trapezium shaped things. The mechanism is like that. It can actually control the whole dia that will be created. Are you understanding? If you open more, the hole opens more. Otherwise, you can close it also. So iris, this is my iris. This is my iris. And when the iris opens up, then there is this hole created, which is known as my pupil. So the pupil size is actually controlled by the iris. Have you understood? And the iris forms a part of your biometric. Everyone's iris is different. So if you've got for your passport and other things, they'll always ask you to look into this thing. Your iris data is captured. My iris, your iris, everyone's iris is different. Have we understood this? It's like fingerprint, unique, yeah. If the iris is closed, at that time the pupil is also closed. So you can't see, right? So the iris is a mechanism. And the mechanism of the iris starts making what is known as pupil. Your pupils can increase in size or they can decrease in size. Generally, we belonging to the Indian origin, our pupils are usually what? Dark black in color. So if you go to like Czechoslovakia and other side, there you'll see ladies and all having hazel eyes. You'll see greenish. From your brains? That depends upon the signal that's giving, yeah. No, it's not. Blind is a separate concept. Blind people, rays are getting, images are not getting formed. So once the iris opens, the iris will control the opening of the pupil. Let's start giving you an example. You must have gone to a movie theater where you are already seated and the movie has started, right? And you are sitting inside the movie theater and it's dark, but sufficient. You're sufficiently comfortable to see who is sitting around you. Children, listen to me. These are all diagrams you'll get in book. If you are interested, at that time, what you can do, you can always start the video and start drawing. But try to absorb. In a class, this drawing is not important. You cannot match my pace of drawing. Let's just understand that. I am drawing, you are also drawing. It's not possible. You try to absorb. So you're in a movie theater, inside a movie theater, and it's been quite some time. And you're seated. It's dark. But the light is sufficient for you to see who is seated next to you and around. At that time, you will see some people, whom I always call the disturbing people, who have a deliberate habit of entering late into the theater. Once they enter late, they are absolutely unable to walk. They'll be walking like this, and you will be actually laughing at him. But actually, you'll also. So what has happened to him? He has come from outside. Have you understood? So at outside, there is a lot of bright light. So when the light is bright, the pupil need not open that much. Have you understood? So his iris is actually adjusted in such a manner that his pupil at that time is very small. Like he's walking in front of, say, in orbit mall, he's walking on the floors and everything. Then he suddenly gets into the theater. Once he has gone into the theater inside, it's dark. Now the eye is sending a message to the brain that, yeah, if it's like LAPD and all this, come on, Roger, open up, come quick, very quick. But it takes time. It's taking time. So that opening of the iris has sense, yes, I need to open, but that opening will take time. That's the moment where that person is actually struggling. Now let's take the reverse. You are watching a movie, now the movie has ended and you need to get out. When you get out outside the movie theater, don't you become like this? Because your iris was so open that your pupil was very big. And now suddenly with that much big pupil means so much big aperture, you have come outside. The brain is saying, Roger, shut down, reduce. So your reduction is not happening so quickly. That's why you'll see people, or somebody wakes you up. Or say our friend Abhigya, now she's ill. She might be sleeping on a bed in a room with just subdued light. Then suddenly somebody is going to search something, switches on the tube light. Don't you begin like this? Why? Because a lot of light has entered. Your pupils are bigger. Have you understood? So iris can control the size of the pupil, and the pupil will actually determine how much of light is entering into your eyes. And this is regulated by the supercomputer called the brain. The brain will adjust. That is what here the processors will calculate. Okay, shutter speed 1/200. This is your aperture, this much light. Right now, when you open up a camera, what does it say? This light, this light, this light, they adjust. That much of calculation your brain is doing much more faster. So the human being is a much more supercomputer than that. Done. So have we understood this? After this, what happens is there are whether they are important in your syllabus or not. So there are two muscles out here. Okay. Now these are called the ciliary muscles. Okay. These are called the ciliary muscles. And in 10 we will understand them very nicely. And here will be your lens, and the lens are actually held by some ligaments, and these ligaments are called suspensory ligaments. Suspensory ligaments. May be important, may not be important. Grade 8, nobody will ask you to draw. Now this is your lens. The eye lens is very interesting. This is like a gelatinous lens. Now when you see the lens of the camera's lens can actually open and close based on how you're focusing. Keeps on opening, right? Those telephoto lenses you can. This thing also your eye lenses can do based on your way. How it does? Actually these ciliary muscles are very flexible. If they start contracting, then the suspensory ligaments become tight. Try to understand. If this muscle contracts, relaxes, contracts, then the ligaments become tight. When the ligaments become tight, this same lens will now become slender in shape. Sorry, I need to use the yellow color. So what I'm trying to say, the eye lens's curvature can actually change based on how you are seeing. This property of the human eye is known as accommodation. Accommodation of the eye. Let's see an example. Do you see that person? Where is he? Oh, there. See, we can immediately see something far off. Can you see my palm? Yes, we can see something very close. Whereas, I don't know, in movies and all, have you seen, like in cricket, if you're covering a cricket match with a camera, if you're focusing on the bowler and if the bowler is on sharp image, the crowd will be blurred. In movies also, they show some scenes. Like if when somebody is talking to someone, if this person is on sharp, blurred. And if you make him sharp, he goes blurred. Camera is not intelligent to focus both together, but our human eye said, can you see somebody in Pearl Tower? We'll immediately we want more light, we can see that also. And we can see something very close by. This ability of the human eye to see something far off and something close by adjusting the curvature of the lens, we can adjust our lens curvature spot on. And that is done by two things just. We make this. So we are just relaxing on this particular muscle. The ciliary muscles are very, very intelligent muscles. They will actually cause the suspensory ligaments to be either tight, So when they become tight, the lens becomes slender. And when the ligaments become loose, the lens becomes fatter. Okay, so we are able to converge light, and that will be in grade 10 level. We will be able to see, adjust. No, if you, when we see nearby things, we make our eyes bigger. So we will be able, converging becomes much more faster. Okay, so this is called the accommodation of the human eye. Now, when we age up, right? Now, so this is an interesting topic. We have to leave it halfway, anyways.
Sorry?
So one small thing. As you age, no, I won't be able to finish that. Let me keep it this drawing here. We will carry it up in the next class. Okay? Yeah. Somebody wanted to say something. Bolo bitu? Suspensory ligaments. Suspensory. They suspend it. A little one has also come. Suspensory ligaments. Okay? It's like this. The lens is suspended like a cable. Niche se bhi, it's like, have you seen babies in village kept by two wires tied on both sides? So those wires are the suspensory ligament and the baby is the lens. Right? So in our next class, we will see the more magic that happens beyond it. Now, you need to understand, like you cry, right? There is something called aqueous humor. There is something called vitreous humor. Your eye lenses always need to get flushed every now and then. Tears are good for health. That's why there's an eye drop available. The name of the eye drop itself is Tears Natural. It costs you something like 200. It's nothing but a bottle of tears. So keep on flushing. Those we will talk. This is very interesting. Whether it's a part of your syllabus or not, let's enjoy this discussion in our next class, where we will talk about how to take care of your eyes, what you should do, what you should not do. Right?